Wait, let's talk about the lab,
Let's
the
talk about the
Oberg
lab.
Astrochemistry Lab. Tell me what's going on there.
Yeah, so what we try to do in the lab is simulate the conditions that you have in space where stars and planets form,
Hmm.
and really figuring out what kind of chemistry you can have happening just as planets are assembling. And then that really helps us to predict what kind of molecules you end up with what kind of molecules you end up with on planets, whether you have water there, organic molecules, and so on. So if we think about what we have to do to simulate those kind of environments, we need to get to very high vacuums and to very low temperatures.
Right.
So a lot of what we do is we build experiments or build vacuum chambers that allow us to do that, to get many orders of magnitude lower pressures than we have here in this room, and also to temperatures that are not that far from the absolute zero, so the coldest uh, temperature you can actually get to just physically.
Interesting. And so you guys don't cool down the entire room, right?
No, that would be very uncomfortable for the graduate students working on it.
I imagine so.
Yeah, so we cool down as little portion of the instrument as possible to still do our experiments, which is really just the size of a dime. It's really a very small
Interesting.
part.
So in something so small, what are you hoping to see within that?
Well, what we do on that part of the experiment that we have cooled down is that we build up very thin layers of ice, only a few molecules thick, which is exactly what you have in space and where most of the chemistry happens in space. Is actually on microscopic dust particles that build up these really thin ice layers. And that's the chemistry that's going on in those sort of icy grains, is what we are trying to simulate in the lab.
Interesting. Interesting. So with a planet forming, how how often does this actually happen in space? I guess we can't really observe it because they take what like probably millions of years to actually form fully. But if we were to look at the universe and how it's expanding pretty rapidly, and we take things like the Big Bang and how galaxies are formed, it seems like it would be almost at chance that a star is able to form. So, what are the chances that it even has all of the materials it needs to form a star or planet?
Okay, let me take that question apart because there are a few
Okay.
different things going on
All
at
right.
once. So, which has to do with the different scales that we have to consider when we think about astronomy. So, you have the largest scales, which is the universe as a whole. So, when
Mm-hmm.
we talk about the Big Bang and the expansion of space, we're talking about what's happening on very large scales. So, scales that are considerably larger than a galaxy. So our own local galaxy, the Milky Way, has a few 100 billion stars in it, and that's sort of our local galaxy. You will not notice the expansion of space within the galaxy. The galaxy just stays bound together.
Right.
So it's in the context of these galaxies, which are still super big, that stars form. So within these galaxies, you have mostly stars, but you also have dust and gas that are swirling around between the stars. And it's from this dust and gas that new stars form. And you're right in that it takes millions of years to form stars, which is actually not that long if you think about how old the universe is, sort
Right.
of 14 billion years almost. But it's longer than a human can sort of sit around and look for it. So instead, what we do is that we can tell when a star is very young, when it has just formed. So we can count how many stars that are super young that there are, and then we know that they only stay young for a few million years.
Mm-hmm.
So you can divide that number by a few million years, and then you get how many stars form every year.
Interesting.
And in our galaxy alone, around 7 new stars with planetary systems form every year.
Every year, and that's since the beginning of this galaxy. So it's been going for a long time.
It's been going for a long time. Our galaxy is about 10 billion years,
Yeah.
and our solar system around 5 billion. So yeah, we have been forming stars for a long time, and as I said, around 7 per year for a long time.
It's a lot of stars. So then, a lot of stars, if I'm remembering this correctly, because I took a seminar with Avi Loeb, and if I'm remembering this correctly, a lot of stars die in their infancy. Is that
They
right?
do. And the bigger the star, the sooner they die.
Yeah. Yep.
So when you're talking about the star like our sun, which is sort of a small to medium sized star,
Mm,
that one lives for almost 10 billion years. But the really massive stars can live for only a few million years.
mm.
And tiny stars can live for much longer than the age of the universe. So it
Wow.
really matters, yeah, what size of a star you are for how long you're going to live.
Interesting. Why? Why? Yeah, why?
Well, you can think about it as the bigger the star, the faster it's burning through its fuel.
Mm,
So a, a massive star gives off enormous amount of energy, but that means that it has to very rapidly convert its hydrogen into helium, so it runs out of fuel much faster than a smaller star does.